And then
So
you get 2.
yeah, x is 2. Good. Okay.
Okay.
Now already encoded in this, what is the y value? What does it say that y is?
-1.
Y is -1. Yeah. So you know the intersection point. It's at y -1, x2, or x2, y -1. All right. So that's kind of the first thing. Is like, all right, we already know the answer now, which is good. Now, in terms of graphing, which is what you're really asking me about here, we want to look at the second equation first. Okay, can you tell me the slope of the second equation?
The slope is -5/2.
Yes. Now, here's what that means. It means down 5 and right 2. The
Okay.
reason it's down is because of the negative. All right.
Okay.
And then right 2, that's always right 2. Okay. Now, what
Okay.
is the b value?
The b value is +4.
+4. Yeah. Now, when you're graphing, you start with the b value.
Okay.
All right. Now, from the b value, you're going to go down. You're going to go down 5. So down 1, 2, 3, 4, 5, and then right 2.
Okay.
Is that all right?
Yes.
Okay. Now you only need 2 points for a line, so you could graph more, but that's all that's needed for that.
Okay.
I'm not seeing what I want. Oh, I'm sorry. I am seeing what I want. So so this line looks like this. Okay. Now we're going to talk about the other line. Okay, this is a horizontal line. Anytime it's in the form y equals a number, you have to know that that's a horizontal line.
Okay.
All right. So what that means is you say, oh, it's a horizontal line, and it means that it goes through -1. There's
Yes.
-1.
Go down 1.
And it also goes through that -1 and that -1. In other words, the way I read it is that it's y is always without exception, always -1.
Okay.
So it's a horizontal line through -1, and you can see that it intersects where we expect it to, which is at the point 2, comma -1.
Okay.
Now for maximum points, you probably want to label each equation. You want to say that this is the red one is y equals -half 5 halves x plus 4. You probably want to say that the other one is y equals -1. And you probably for sure want to label the axes with the grid points, x, and a y like that.
Okay. Thank you.
So do you feel like you could do this on your own, the problem like this now?
Yes.
Okay, great. We can go on to number 2 if you're ready.
Yes. Okay.
All right, so number 2, a little bit harder. You have the same thing. You do want to graph. This one's not as easy to solve by hand before you graph. So we're just going to go ahead and graph these. The best way to graph something is if it's solved for y. So meaning y is by itself.
Okay.
Now, when you look at like equation 1, x plus 2y equals -4, is x by itself? I'm sorry, is y by itself? Excuse me. Is y alone?
No.
No. It's got this x and it's got this 2. So we're going to
Yes.
first subtract x from both sides. 2y equals -x -4. right, is that okay?
Yes.
Now, you noticed here, and this is my preference. Sorry, my screen just a little slow here. That minus X goes before the net, before the -4. Like you have to kind of sneak it in front. You don't want to put it after. And the reason is because it's mx plus b. So that
Okay.
X comes before the number. All right, now, what is keeping Y from being by itself here?
The 2.
The 2, and it's multiplied by 2, so you divide by 2. Now you divide everything by 2. Okay. Now it's probably not too bad over here on the right. 4 divided by 2 is 2, or -4 divided by 2 is -2. But there's really a 1 in front of the X, or -1. And that's the way we want to write it here. -1/2 X minus 2, like that.
Okay.
Now give me the slope and give me the b value.
The slope is -1/2 x,
No,
and the b value is -2.
okay, so the b value is -2. Now the slope is just a number. It's
Okay.
just a number.
So
What's the number?
-1/2.
-1/2. So that means down 1, right 2. Down 1, right 2. So let's make a graph here, or you've got one. You've got more room than I probably have in here. So you start at the b value. And from here you go down 1, right 2. Down 1, right 2. Are you able to graph it on your side, or maybe it's already there?
Yes.
Okay.
I'm
Now,
graphing right now.
if you need to go the other direction, like if you're like, well, I don't know where this thing's gonna intersect, you don't try to go backwards. You just figure out a point. And you say, well, from this point, is it down 1, right 2? And it is down 1 and right 2. So you get those points there,
Okay.
and you're happy. All right. So now we're gonna look at the other equation. All right. So I'm gonna have to go down here a little bit. The other equation is 3/2 x plus y equals 2. So is
Yes.
this solved for y? Is y by itself?
No.
Okay. So you're going to subtract 3/2 x from both sides. And again, like you really want to put it in front of the number. So it becomes y equals -3/2 x plus 2.
Okay.
Okay. What is the slope? What is the b value?
The slope is -3/2,
Good.
and the b value is 2.
Okay. Now, in the slope in words, are you going up or down?
You're going down.
Down 3, right 2.
Yes.
Okay, so now I'm gonna go to the b value. You always start at the b value. The b value is at 2. And then you follow the instructions here. You go down 3, right 2. So 1, 2, 3, right 2, down 3, right 2.
Okay.
And hopefully they intersect in a nice point.
Yes.
Okay, so they do. Can you give me this ordered pair here?
The ordered pair is 4, -4.
Okay, good. All right, now again, like, few good things to do would be to label each of the graphs. Label that it's 1 and 1, x and y. These are all things. Put arrows at the end of your lines, things like that.
Yes.
Okay, now let's go back and let's check your answer. We haven't done this yet. Do you know how to check if 4, -4 works?
Would you plug it into x and y's?
In both equations, yes. Yeah, so you check it in each
both,
equation.
yeah.
So x plus 2y equals -4. So that's 4 plus 2 times -4 equals -4. Okay. And you're just checking, like, does the left side equal the right? So 4 plus -8 or 4 minus 8 Are these the same? Yes, they
Yes.
are. And then you do the same thing for 3/2 x plus y equals 2. So 3/2 times 4 plus -4, does that equal 2?
Yes.
It does. So that's 6 plus -4 equals 2. 2 equals 2.
Okay, thank you.
So you can always check your answer. Whether you have time to do that is another, another issue altogether, because it does take time to check. You don't just, have infinite time to be able to do that. All right, so that takes care of those questions. Do you want us to look at number 3 next?
Yes,
Should we
please.
go in order? Okay. All right. There it is. Excuse me. 3 is very similar to what we just did, where you're going to check the solution. All right, so here's the problem. It says determine if 3 comma 1 comma -1 is a solution to the system. Okay, it's a solution, meaning it works if it works in all of them. So you might even want to make a note,
Yes.
must work in all. Okay. Now I teach an SAT, ACT test prep course, and like if teachers, it's either going to work in all or it's probably going to fail in the last one. So if you're like trying to save some time, you might start from the bottom up here. But
Okay.
you unfortunately did test it in all of them, because if the first 2 work and the last one fails, then it doesn't work. So either, unless it fails in the first one, which it probably won't, you're going to end up testing, and testing. So it's just a, how quickly can you evaluate these? So 3 plus 2 times 1 plus -1, does that equal 4? What do you say? Does that work?
Sorry, I'm just trying to do it on the calculator.
Okay. Are you allowed to use a calculator on this?
Yes, you said we are.
Oh, good. Okay.
So yes, 4 equals 4 for that one.
So it works for
This
that
one.
one, which really
Yes.
doesn't help us, because we got to try the others, right?
Yes.
So -3 times +3 minus 1 plus 2 times -1. Does that equal -12?
Yes.
So that one works as well, which means we now have to check the last one. 2 times 3 plus 2 times 1 minus -1. Does that equal 8?
I saw no, it doesn't.
It does not. So isn't that
Yeah.
frustrating?
Yes,
You
it
get down to the very last one and it doesn't work.
is. Yeah. Yeah.
And that's just the nature of these things.
So you're saying start from the bottom at all times?
Well, that's a test taking strategy. I mean, you should just go top to bottom, but the
Okay.
that's the kind of thing I would teach you in that class. That's for standardized tests. Um,
Okay.
all right, so that takes care of that one. So for it to be a solution, it has to work on all of them. Now, when it says here, what does the answer yes or no mean about how the ordered triple and the system of equations are related? I guess they're looking for something like consistent, possibly. I'm not really sure what your teacher means here. So graphically, and you don't need to know this, but graphically, it's three planes here
Mm-hmm.
that are intersecting. So if you can imagine what that might look like.
Okay. This looks
So
a little bit different.
yeah, it's a little odd. And don't take too much from that because you're never going to see that again until much later in your math career if you go that
Okay.
direction. But I would guess I would go to the teacher and be like, I don't. What do you mean by that? What am I supposed to be answering here? Remember we made that flow chart about whether it was consistent or inconsistent.
Yes.
So consistent means that it has a solution. Inconsistent means it does not. So this is no solution. This is the solution.
Yes. So it is inconsistent.
Yeah, well, yes, exactly.
Okay.
So that's
So how would the explanation be? Just
well,
saying
I'm
it's
not sure. See, I'm not
inconsistent?
sure that this is where you want to give your teacher exactly what they want.
Okay.
So this is one of those to go back and ask and say, hey, I was working through this. I don't really understand what you want here. I mean, I know it's not a solution. What do you want me to say? Inconsistent, no solution, things like that.
Okay. Are you still there?
Yes, just needed to
Okay.
respond to something real quick. So we'll move on to
Okay.
number 4. Does that sound good to you?
Yes.
All right. Now, another back to graphing. I don't really, I mean, these aren't really in any particular order, but we're back to graphing. Yay. Uh, when you're asked to graph something, there are many ways to graph, but for you, the best thing to do is to solve for y. Like we need to keep it simple. We need to keep it consistent where you're just doing the same thing over and over again. So I'd like you to try solving this first equation for y, please.
Okay.
And if you're not sure,
Wouldn't this just be elimination though? Because both sides are opposite.
again, we want to graph. Like you're not trying to use elimination.
Oh, okay. We're not doing it. Okay.
All right, so whenever you get that solved for y, let me know what you come up with.
Okay. So y would equal 5?
No. You're solving for y, so you're going to subtract 2x from both sides.
Yes, I did that. and then I got y by itself, and then 5. Is that
remember the minus 2x goes up in front. It's like y equals minus 2x plus 7.
oh, okay.
You cannot combine them. Remember the eggs and bacon example we talked about?
Yes.
So it's like 7 eggs taking away 2 strips of bacon. You still have 7 eggs.
Okay.
Okay, now
So
what is the slope of this
the slope is -2.
over 1? And the reason that 1 is there is because we're always going to the right.
Yes.
Now what about the -2? What does that mean in terms of up or down?
That would mean down.
Down 2. What is the b value?
7.
7. So we're going to start at 7. So let's go over to our graph here. 1, 2, 3, 4, 5, 6, 7. Wow, right there at the top. Down 2, right 1. Down 2, right 1. Down 2, right 1. Okay. Now, I don't know how many tell you to graph. You need to graph enough so that your line looks relatively straight. The teacher doesn't want to see, a wavy line.
Okay.
Okay. Now, in terms of the second equation, I'm going to write the second equation here. We'll solve this together for y. So you're going to add 2x to both sides. Okay. So this is minus y equals, now that 2x goes up in front of the 6. So it's going to be 2x plus 6, like that.
Okay.
Now there's a
And then our
negative.
slope would be
Well, wait, hang on.
Oh,
See
go
how,
ahead.
hang on. Y is not alone. I mean, it looks alone, but what about that thing in front?
negative.
Yeah, so you have to get rid of that. You divide everything by -1. So that results in y equals minus 2x minus 6.
Okay. And then our slope would be -2 over 1.
Good.
And
What's
then
your b value?
it would be -6.
-6, yeah. So this one's a little harder to graph. I don't know why they chose that, but there's -6. I think 1, 2, 3, 4, 5. Nope, it's down one more. Now this one's, we can't even graph. So you're kind of estimating where those points is. So you can always go backwards. Like at that previous point, if you go down 2 and right 1, that it gets you to the previous point. And then you sort of say, well, where do I need to be so that if I go down 2 and right 1, I get there, and so on. Don't try to like do things like, opposite, up, down. Just keep always go left to right here.
Okay.
Now, I'm not drawing these great, but do you notice, is there anything about these lines that stands out to you?
They're both parallel.
They're parallel, yeah. And that means there is no solution.
Okay. And
Because
that's what it means
because
graphically.
they never intersect.
And that's what you would put for the last
So,
question at the
yes,
end.
so that I think what your teacher's trying to do is ask you some questions like this because you're going to get something
Mhm.
else where you have to answer it. It means that they never intersect. And you don't need a lot of words. You just need to say does not intersect, does not cross. Like less is more.
Okay.
All right, so we have some options here. I know you got 7 on there. 7's kind of its own. 7's kind of its own problem. 9, 10, 11, these are story problems like we've been working on. Those might be good. Same with 11, 12. Those might be good to write out. It's up to you. We have enough time to talk about 7.
Okay, can we do that? That's
Sure.
probably the hardest one.
Yeah, these
Okay.
are, and most, so here's the typical student will say, Mr. Teacher, Mrs. Teacher, are we gonna have like one like 7 on the test? You never ask that
Yes.
question. You never ask that because
Oh,
you should
okay.
just because you should say to yourself, you say, you know what, I want 7 on the test because I know how to do it. Because the one
Okay.
that you ask that
He's
you don't know how to
prepared.
do, like you're doing, sorry, forgive me, is it jujitsu?
Yes.
Okay. Like you don't say, I hope the opponent doesn't do move X, right? You say, no, if they do move X, I'm going to do this thing. I'm going to block them and I'm going to do this in return, whatever that is, right?
Yes.
You don't hope they don't do something. You're like, no, I don't care what they do. I've got an offensive strategy for every defense. Offense, anything they throw at me offensively, I'm going to block and I'm going to come back at, right?
Yes.
Okay. So, yeah, but having said all that, I mean, these are really long. These are really, really long. And they're not, there's some things here that they don't look great. um so you can sort of shortcut this by looking for where the y and like z are isolated. That kind of helps. But what a lot of students do is they just always eliminate x to start. And I guess
Okay.
that's my question to you is, do you remember what you guys did in class? Did you just always eliminate x, or did you look for like other things to help make these easier?
So we did this like
Did you use
last
substitution?
test, and
Sorry.
I think we'd use substitution. Yes.
Okay. All right. That's where I was going with this. So because the second equation has y by itself, you can solve for y. So we're going to do that first.
Okay.
So we've got minus 3x plus y plus 5z equals minus 5.
Okay. And then you just go from here.
Well, we got to solve it for y. So we're gonna add the 3x to both sides. So that's y plus 5z equals minus 5 plus 3x, like that.
Okay.
And then, and see, I don't even know if we want to do it this way. Did you really use substitution?
Um, like we worked a lot on substitution, so yeah, I think we did.
Let's do, okay.
But if there's an
Let's do
easier
this.
way, then I take
Yeah,
it.
let's do elimination because that's what
Okay, sounds good.
you seem to like, and I kind of agree with.
Yes, I do.
Okay, so we're gonna look at what we're gonna do first. We're gonna look at the first two equations.
Okay.
All right, so we're gonna rewrite those minus 5x plus 3y plus 6z equals 4, and we're just gonna arbitrarily choose to eliminate x.
Okay.
So to do that, we're gonna multiply the first equation by, I'm gonna just choose -3, and the second equation by 5. So
Wouldn't you do +3? Because you're trying to do opposite.
well, they're currently same sign. So if we don't
Uh-huh.
make one of them negative, it's going to end up being um, same sign. So one of them's got to flip. So that first equation, -3 times each of those.
Okay.
So that ends up being 15x minus 9y minus 18z equals minus 12. Similarly, you're going to multiply the 5 by everything. So you get minus 15x plus 5y plus 25z equals minus 25.
Okay.
So that's minus 4y plus 7z equals minus 37. And you really, really hope you've done everything right. You feel like you hope you've gotten all the signs correct.
Yes.
All right, now we're going to go back and we're going to use the second two equations. So the minus 3x plus y plus 5 equals minus 5, minus 4x plus 2y plus z equals 13. A lot of writing, lot of writing.
Yes.
So let's write those here. Minus 3x plus y plus 5z equals minus 5. Minus 4x plus 2y plus z equals 13. So we're going to multiply the first equation by 4 and the second equation by 3.
Okay.
So again, just really paying attention to your signs here. So now when you add vertically, you get this equation right here. I really hope I haven't made any mistakes. Let me know if you have any questions or get caught up here on this.
Okay, I'm caught up.
So then you go back and you grab your other equation. So that other equation, kind of the nice thing is that they're both, see how they both just have a y and a z in them, or you can think of it as x and y,
Yes.
but you're down to two variables. But you end up doing elimination again, and we'll just eliminate y. We'll multiply
Okay.
by 4 and then by 10. So this is where you may want to grab that calculator. 212z equals 76 minus 40y plus 70z minus 370. Now it looks bad, but it probably works out just fine here. Although this is not looking good.
Okay. Sorry for the background noise. There's
That's okay.
tiny
Yeah,
leak.
so this is not working out nicely. I made a mistake somewhere. I got to go check. This is the problem with these. If you make one mistake, it ends up propagating through the whole problem. So 15x minus 9y minus 18z minus 12. And then times 5. 15x, 5y, 25z minus 25. Okay, now we add minus 4y, 7z minus 37. So that looks okay. Must have been here. Oh, there's the problem. I didn't copy the negative down. So
Okay.
that's why this didn't work, because I have to multiply by negative 4, which changes this to negative 4y, negative 20z, positive 20. Sorry. This
No,
is
you're okay.
this is why this is so, you got to be so careful here. So let me gotta start over on this part here. Get rid of all this. So if you get 2y plus minus 17z equals 59. And then let me grab that other equation. So now we're going to eliminate the y here by multiplying by 2. 4y minus 34z equals 118. Add these up, you get minus 27z equals 81, and then you get z equals minus 3. So if you didn't follow that, we'll do another example, or we can do it next time, another example, but you have to practice these 3x3s to get comfortable with all the steps, okay? But this is only
Okay.
this is only 1/3 of the answer because it's X,
Yeah.
Y, and Z. Now when you get this though, you're really close. So you just go back to your equations that have Y and Z in them. Okay, so like maybe you like this one. See how it's just got Y and Z in it?
Yes.
And you use it now to find Y. Okay. Now I know normally we like
Okay.
pick one, but this is it's it gets so messy, you just grab the first one you see. Minus 21, minus 37. So you add 21 to both sides. Minus 4y equals minus 16. Divide by minus 4. Y equals 4. So now we're in really good shape. Now we're really good because we got both a z and a y.
Yes.
We have z is minus 3, y is 4. So what I'd like you to do, and you can pick any of the original equations, but I want you to use the fact that z is, what did I say, minus 3? Yeah, minus 3, and y is 4. Any one of the original equations and solve for x.
Okay.
And let me know which equation you're using.
Okay, so I'm using the first equation.
Okay.
And we plug in both y and z,
Exactly.
correct?
Yeah. Because it
Okay.
only that leaves one variable remaining.
Yeah, that's true. Okay, so I think I messed up somewhere.
Okay.
Trying to figure out where.
What's 3 times 4?
The 12,
12. And then 6 times minus 3.
negative 18.
Good. Say, so now you got to combine like terms. What is 12 minus 18?
12 minus 18. Negative 6.
Negative
Okay,
6.
so that's where I messed up.
Okay, so you're gonna add 6 to both sides.
Okay.
All right, so there's your answer. You got x is minus 2, y is 4, and z is minus 3. Now, believe it or not, that
Yes.
problem took us 12 minutes to do. You know, I made a mistake, so
Yes.
that cost us 2 minutes, we'll say. But these are long. These are going to be the longest problems on the test. So just keep that in
Yes.
mind. You know,
I'll probably save this for last.
yeah, and you know, it does you no good to get that one right and all the rest wrong because you've got to make sure you get as many done on the test as possible. So
Yes.
let's go to 9, 10, and 11. And with these, I think the important thing for us tonight is to set them up, not necessarily
Okay.
solving
That's
them.
fine.
And if we've got time, we'll solve some, but I think that's really the key thing here. So let me snip in number 9. Okay, so the says a movie theater charges $5 for an adult's ticket and $2 for a child's ticket. One Saturday, the theater sold 785 tickets for $3,280. How many of each type of ticket were sold? Okay, so please give this a
Okay.
try. See if you can work out what the equations are, and
Yeah, I can do it.
and let me know when you're all done there.
So A plus C equals 785.
Okay, agreed. That's the total tickets equation.
Yes. And then A5 plus 2C equals 3280.
Perfect.
Okay.
Now you can make a note here. You can solve by either substitution or elimination. I think you've been choosing elimination. But this would be a
Yes.
good one for you to try on your own.
Okay.
Okay. Really, on your own, not right now, but like,
Yes, yes.
later on, um, and see what you come up with. So let's go to number 10. 10, look,
Okay.
10's got more words. It doesn't necessarily mean it's more difficult. All right, so it says, suppose the owner of a candy store mixes two types of candies. She decides to create a 20-pound mixture of raspberry flavored gumdrops and cherry flavored jelly beans. The gumdrops sell for 95 cents per pound and the jelly beans sell for $1.20 per pound. She plans to sell the mix for $1.10 per pound. How many pounds of each candy should she use in her mix? So the question always tells you the variables, the pounds
Okay.
of each candy. Okay. And if you go back and look, there's raspberry and cherry flavored. So those are your two variables. The question always tells you the variables, almost always. Okay.
Okay.
So in this one, there's what I'll call a pounds equation, and then there's a money equation. Pretty sure you can come up with the pounds equation. The money one's a little bit harder to
Okay.
come up with,
So
but give me the
R
pounds one.
plus C equals 20.
Yes.
Okay.
All right. So the money equation it's got a certain format. It's dollars times amount plus dollars times amount equals dollars times amount.
Okay.
So notice there are, and I'm going to highlight these, there are $3, 95 cents, 120, and 110. Dollar, dollar, dollar. Now the amounts are the variables. So which dollar goes with the R?
0.95.
0.95. Which goes with the C?
0.120.
Okay. And then the one on the right here is the mixture. What's the mixture
That
of the
would
dollar?
be 1.1.
1.1. Now the mixture contains both R plus C, but what is the value of R plus C?
20.
20. So you don't put that, you actually put 20 in there.
Okay.
So here are your two equations to kind of summarize this. R plus C equals 20, and then 0.95 R plus 1.2 C equals 1.1 times 20. And that would be, again, a good one. It's harder than 9, but it would be a good one for you to try on your own.
Okay.
With the time we have left, let's set up number 11
Okay.
and see if you can do that. Go ahead and read this to yourself and see if you can come up with the two equations. If you can't, I'll maybe draw a picture, see if that helps.
Okay. So X and Y equal 90.
Okay, very good.
And then I think it'd be like 90 equals x2 plus y.
So we're focusing on this part right here. If one of the angles is double the other
Yeah,
angle.
double.
Okay, so
Yeah.
pick an angle. Pick either x or y.
So x.
X. X is x equals. Is means
Okay.
equals. What is
Okay.
double? What is double as a number?
2.
And what is the other angle now?
Y.
There you go.
Okay.
So there's your other equation.
Okay, thank you.
So you should try solving this with substitution.
Okay, sounds
Okay.
good.
Now, just to be reasonable here, do you have time tomorrow to do this?
Yes, I do.
Great. I would recommend starting with that. And then let me
I
just
will.
stop the recording here.